So remember section 5.1, we talked about all the different rules that we have for working with exponents. We learned how to multiply them when you have the same base and two exponents. We learned how to divide them. We learned how to take the power of a power. We learned how to take a product and raise it to a power. And we learned how to take a quotient and raise it to a power. And everything we did was all positive exponent answers. Today we're going to move into what happens if there's a zero exponent and what happens if there's tapping it before you open is probably not a great plan.
Sorry. I didn't tap it.
Me did.
Did I?
And what happens if there's a negative exponent? So that's what we're going to look at tonight. And we're just covering this one section. So zero exponents and negative
Were you
exponents.
doing this one?
Tonight, yeah.
Yay.
So we should get done early, hopefully.
I thought we were doing all of them.
No.
Just 5 by 2.
We're going to do 5.2 tonight, and then we'll do 5.3, 5.4, 5.5 next week.
Okay.
Or
Oh,
5.6.
that's easy, I think.
Thank you.
You're confused already?
Yeah.
Thank you so much.
3 minus 3 is 0.
So, looking at this, let's think about simplify using the quotient rule. What does our quotient rule tell us here about this situation? Well, and I think Sally just said it. We would subtract the 2, right? 3 minus 3. And what happens when you get 3 minus 3? You get a to the 0 power. So the question that we have is, what does that mean? Okay, and we're not going to answer that question yet. We're going to do another version of this. Let's simplify this using the definition of exponents. Okay, now the definition of exponents means we want to think about this as a times a times a, because that's what a cubed means, right? And a times a on the bottom. Now, if you remember what we did last week, we talked about canceling these, right? Because if you take a divided by a, what do you get?
A.
No.
0.
You get
1.
1. Anytime you divide something by itself,
I meant 1.
you meant 1. And
I
then
know.
this, same thing, right? And then this, same thing. And it makes sense. If you take something and divide it by itself, your answer should be 1. So what we find out is anything raised to the 0 power is actually going to equal 1, because it basically ends up meaning that it's divided by itself. Okay?
Can we put the 1 up there? Or no?
You don't want to put the 1 as the exponent because that changes. That means there's one a. What we're saying is there are no a's.
The whole
There's just a
1.
1.
Right.
So here's our rule that any number raised to the 0 power is just equal to 1. So no matter what you see, if you take 10 raised to the 0 power, 1. Negative 13 raised to the 0 power, 1. 100 trillion raised to the 0 power, 1. Anything raised to the 0 power is 1, with one exception. 0. You can't raise 0 to the 0 power.
That is 0.
That's undefined. You just can't do it. Okay?
0 power 0 is 0.
No, 0 to any other power besides 0 is 0, but 0 to the 0 power is undefined. Because think about what we just did, right? How did we get a to the 0 power? We took a cubed divided by a cubed, so something divided by itself. Well, the problem is 0 divided by 0. You can't divide by 0. Okay, it's undefined. Anytime you try to divide by 0, it's undefined. So that's the one number you cannot use. But anything else raised to the 0 power is always going to be 1. Okay, anything except 0.
0 by 0 is the answer is 0, right?
No, it's undefined.
We put in a
But,
0 times 0 is 0, so the answer
That's
is 0.
true. But you can't do 0 divided by 0. Think about what it means to divide something.
That's not even
You can't ever divide anything by 0. That's the 0 is the one that creates problems for us, because any other number you can divide by, right? Okay, so if you take one pizza and divide it into 0 pieces, does that make sense?
You have a pizza.
If you have something,
have a pizza.
yeah, if you have something, you can't divide it into 0 parts.
Uh-huh.
Okay, so there is no dividing by 0. You just can't do it. It doesn't mean anything. It's undefined.
I mean, you
Okay.
can do it in the thing, and it's gonna give you.
An error. It won't do it.
So,
You can try it on your calculator, but it won't do it. Okay, so let's simplify this one. Notice what this is. 3 times x squared
One.
raised to the 0 power. It is.
3, 1.
It's 1. It doesn't matter what we raise to the 0 power. It's going to be 1.
So any number.
Any number besides 0 raised to the 0 power is going to be 1.
Okay.
Okay?
So
Got
what if it was, what if we had like a, or am I getting ahead? What if there's a 3 in the front of the parentheses? Then you have the 0.
So you're saying like something like this?
Yeah.
Only, remember this 0 only applies to the parentheses. So it'd be 3 times 1, so that would be 3. But the thing that's raised to the 0 power is still turning into a 1. Does that make sense?
Mhm.
So anything, so the part here that's raised to the 0 power is just the x squared raised to the 0 power. That part turns to a 1. The other stuff is still whatever it is. In this case, a 3. Okay? All right, so let's take a look at simplifying this one with the quotient rule. And I know that's kind of hard to see. I don't know why it's like that exactly, but anyway. Quotient rule says we would take a to the 3 and we would subtract the 5, right? That's what our rule says. You subtract the exponents when you're dividing. That's a 3 and that's a 5. On your paper, it looks much better. That gives us a to the negative 2nd power. Okay, now what does that mean? Well, we're going to use our definition again to help us out. And if you think about it, this is why I like thinking about it as canceling. But if you think about it with this definition, this means this, right?
Mm-hmm.
And the 3 A's on the top can cancel with 3 A's on the bottom. And each of those become 1s. So what do we have left?
2.
1 over, and we have 2 A's left on the bottom. So 1 over A squared. So here's our relationship. A to the negative 2nd power equals 1 over A to the 2nd power.
So when you say 1, what would you get?
On the top?
Mhm.
Okay, because because we're actually dividing here, right?
Mhm.
So, excuse me, A divided by A is 1. So these cancel to be 1s.
Mhm.
A divided by A is 1. A divided by A is 1. So on the top we have 1 times 1 times 1. So that's 1.
Oh.
On the bottom we have 1 times 1 times 1 times A, which is the A squared. Okay. So this is going to give us our rule for negatives. Negative exponents, and here's a big word that I want you to think about. Negative exponents mean reciprocals. Now, hopefully you remember that word reciprocal. That's where you take your fraction and the numerator goes down to the denominator and the denominator goes up to the numerator. It's where you flip that fraction. So notice what we've got. If we've got A to the negative 2nd power, it turns into 1 over A to the 2nd power. To change that negative to a positive, we take the reciprocal of the A. It moves down to the denominator. Okay, and we're going to see there's several different versions of this rule, and we're going to see those right here. And they're listed on your notes. But here are the 3 versions of that rule. The 3 ways that it can work. So if we have A raised to a negative m power, that's the one we were just looking at, what that turns into is 1 over A to the m power. That's one version of reciprocal right there. Okay, so anytime you see a negative exponent, you're going to move it down into the denominator. Except, I mean, that's one way it can look. Notice this one. If the negative exponent is in the denominator already, it moves back up into the numerator. Okay, so it's always going to move either from the top to the bottom or from the bottom back up to the top. Okay. And we'll see a lot of examples like that. I mean, that's what we're covering tonight. So we're going to see a lot of examples like this. If we see this one, A over B raised to the negative m power. Well, reciprocal means you flip this fraction, right? So instead of a over b to the negative exponent power, we're going to flip that and make it b over a raised to the positive exponent power.
Even the sign changes.
When you do that reciprocal, that's when the sign changes. Yep. So it can look like this, because if you think about what this is this over 1. So it's flipping. This is 1 over this. It flips. But anytime you flip it like that, anytime you take the reciprocal, that changes the negative exponent into a positive exponent. That's how we get rid of the negative exponents, by doing the reciprocal. So the same thing happens here. And then remember, this is just our power of a quotient. The m applies to the b, and the m applies to the a. So it will simplify to be that. And like I said, we're going to see a lot of examples like this, but this is the rule that we're going to be using that applies to each one of those when you've got a negative exponent. Okay? So let's take a look at some examples and see if we can apply these rules. Okay? And maybe we should have left more space for this, but anyway. Okay, so here's, again, when we look at these, they're a little bit weird sometimes, but here's what we want to do. What I would suggest is anything that has a positive exponent, we just leave alone in step 1. Anything that has a negative exponent, we'll do the reciprocal and move it so that it has a positive exponent. Okay, so let's see if we can kind of work through this. Notice the a is cubed, so it just stays as a cubed. Okay. I'm just going to circle this for now. We'll come back to it in a second. The c doesn't have a negative exponent, so we're going to leave it where it is.
So you can move it to.
Yep. When you're multiplying, the order doesn't matter. The 2 doesn't have a negative exponent, so we're going to deal with it right away. We're going to leave this one for a second, and we're going to leave this one for a second. And then the f squared has a positive exponent, so it's just going to stay on the bottom where it is. So we've just rewritten all the ones that were already positive. Now what we want to do is take those ones that have negative exponents and turn them into positive exponents. So what does our rule say if this b has a negative exponent up here in the numerator? It says it's going to go down to the denominator. And when we put it down in the denominator, it's going to be b to the positive second power. That's using this rule up here. If it's in the numerator and we want to change it from a negative exponent to a positive, we move it down into the denominator. Okay. So that takes care of that one. What about this d to the negative first power? Since it's already in the denominator, where's it going to go? Up into the numerator. So we don't even have to write the 1 because it's automatically a 1, right? If you want to put the 1 there, that's fine. D to the first power. Just to emphasize it, change to a positive. Then what are we going to do with the e to the negative fourth power? Move that up. And it'll be a positive 4. Okay. Now, actually, there's nothing we can combine here because they're all different letters. Do we see that? So usually at this point is where we would combine them. But what I will say is typically when we write these, we put them in alphabetical order. So the top is already good. A cubed, C, D, E to the fourth. And then the bottom, we've got the 2. Numbers go first. And then usually we put the b squared first and then the f squared second. And so this would be our answer. I think if I remember right on the homework on the computer, what it will do is it will have, well, you either will have to type the whole thing, and you know how you do your fractions and you do exponents on the computer. So you'll get a lot of practice with those this week. And then sometimes it'll just have like b, and then you just fill in the exponent, or c, and you'll fill in the exponent, or d, or whatever.
Were you able to open the other one like this, or just not the 5-1?
Not 5-1. All the other ones should be open for 3. So I was asked to open it up so you get 3 chances on each question, and so I've done that. I mean, my goal is that you get enough chances. I mean, I could open up for a whole bunch, but usually At some point, I have to have you stop. So anyway, but I have opened it up for three chances on each question. So you do have that. Except for 5-1, because I think a couple people had started or finished 5-1, and if I change that, it erases all their answers. So I didn't want to do that. I already did.
okay.
I already did it once to somebody. So
It's okay.
anyway, okay. So does this make sense? The positive, anytime that's anything that's positive, we just leave, but the negative ones we want to move so that they become positive. Because our standard form is we want to write everything, if possible, with positive exponents. Okay. So let's take a look at all of our rules now. So this is all of our rules from last week, and now combined with the rules from this week. So just as reminders. The first rule is if you've got two numbers that have the same base and they both have exponents, we add the exponents together. Okay, from last week. If we are dividing two numbers that have the same base and they have exponents, and we've done that already a couple times tonight, we subtract the exponents because they cancel, right? Here you've got two groups, you put the two groups together, you get more of them. Here you've got two groups that are canceling, so you get less of them. When you have one base with two exponents applied to it, we multiply those exponents together. Okay? If you've got a product with an exponent, remember that m applies to everything inside, so you get a to the m and b to the m power. If you got a quotient, and we already saw this one tonight, if you got a quotient, the m applies to the a and the m applies to the b, so we get that. All right, then earlier tonight, we learned about 0. Anything to the 0 power is automatically 1, as long as it's not 0. That's the one exception we have. And then here are the three negative ones. If it's already in the numerator and has a negative exponent, we will move it down into the denominator to make it a positive exponent. If it's already in the denominator with a negative exponent, it moves up into the numerator. It moves back up to the top. We just don't usually write the 1 underneath it, right? And then if it's a fraction, because that's reciprocals, top goes to bottom, bottom goes to top, and then reciprocals here, you just take the reciprocal of the fraction, it becomes b over a. Both of those raised to the m power. Okay, so that's all the rules that we have for our exponents, and that's really all the rules for exponents. There really aren't any more. It's just application of them in all different sorts of situations. Okay, so let's do some more practice. All right, so looking at this again, the first thing I would do is deal with all the negatives. Get rid of all those negatives. Notice there's no parentheses. If there's parentheses, we have to do some other things, and we'll get to that. But in this case, just deal with all the negatives first. And so that means we can just write down all the positives. We've got a 4, and we've got a 3, and we've got an x cubed. And then we'll deal with this one, and this one in a second. And then on the bottom, we've got a 6 and a y cubed. And then we're going to deal with this one. So what happens with this x to the negative 5th? Since it's on the top,
Move it down.
it's going to go to the bottom and become x to the positive 5th. What happens to the y cubed, y to the negative 3rd? It moves down and becomes y cubed, positive 3rd. And then what happens to the y to the negative 2nd? It moves down and becomes y to the 2nd. And the only one we have to deal with down here is x to the negative 5th. Where does it go? Back up to the top and becomes x to the 5th. Now I will say there are going to be some shortcuts sometimes, but I don't want to confuse anybody with shortcuts now. I just want to show you, if you do it this way, you can simplify it every time. Okay? Now, let's go ahead and combine. 4 times 3 is 12. And then x cubed times x to the 5th is going to be what? Because they have the same base, so it'll be x to the
7.
8. 3 plus 5.
Sorry.
X to the 8. Okay, on the bottom, we've just got a 6. And then let's combine, well, let's go in alphabetical order. So we've just gotten x to the 5th. And then we've got all these y's. What happens when we do y cubed, and y squared?
Yeah.
You add them. So what do we end up with?
8.
Y to the 8th. So I want to pause there and make sure everybody's with us. Does that make sense? Okay. Now, if you remember, when we talked about these last week, you always want to reduce the numbers if you can, and you always want to have only one of each letter. So you might have a number that's a fraction, and that's fine, but you want it to be a reduced fraction. And then you'll only have one x in your answer and one y in your answer, in this case, because those are the two letters we have. So let's start with the number. 12 over 6. What can we do with that?
2, cancel that, right?
It's 2, right? It ends up being 2. 12 divided by 6 is 2. So the 2, and that 2 is on the top, right? Okay.
Yes.
Then notice we've got x's on the top and on the bottom. So what do we do with these exponents?
You subtract.
We subtract them, right? And so we're going to end up with x to the
3.
third power. And where will it be? On the top or on the bottom?
Top.
Because there are more x's on the top.
Yes.
Does that make sense?
Can you start with
Yep. So we're combining the x's.
Yeah.
Are we okay with the 2?
Yeah.
Okay, we're looking at the x's. So you've got x to the 8th on the top, x to the 5th on the bottom. So when we cancel those, we use that rule for division that says we subtract, right? So x to the 8th, x to the 5th, we do 8 minus 5 is 3. And we want to keep in mind, where is that x cubed? Is it going to be on the top or is it going to be on the bottom? It's going to be on the top because there are more x's on the top, right? So when you're done canceling, there's going to be 3 x's left on the top. Notice there's only one y, and it is in the denominator. It stays there, y to the 8th. And once we get our number reduced and only one of each variable, then we're done. And that is our answer. Okay. Make sense? Okay, let's try another one. Now this time, we have some parentheses. And in general, I think it's a good idea. Again, there are some shortcuts sometimes, and the more you do these, you're going to maybe notice some of those shortcuts. But right now, in general, I think it's a good idea to take care of those parentheses first. No, let's still take care of the negative first, I think. Negatives first, if we can. Sometimes we have a choice, sometimes we don't. And the nice thing is, this is all multiplication and division, so the order isn't super important. Okay, so let's write this down, and I'm actually I want to deal with this first, this parentheses. So the issue that we have is the entire parentheses is raised to a negative power, right? Does that make sense?
Yes.
So that means the whole parentheses, what do you think is going to happen?
Change
The whole parentheses goes
Oh,
down
okay.
to the bottom.
Okay.
Does that make sense? Because the whole parentheses has a negative exponent. So we're going to make this 3ab cubed, and now it's going to be to the positive second power. Be careful with this. The a is positive. It stays up there. Right? And I maybe should have done this in a different order. The 2 is positive. It's going to stay there on the bottom. Yeah, okay, hang on. I messed up my order. Let me do this the way I've done the other one so that I don't mix anybody up. Sorry about that. So I'm going to leave this here for a second because it's got a negative exponent. I'm going to leave this here for a second. It's got a negative exponent. The a is positive exponent, positive 1. The 2 on the bottom is a positive exponent, so we're going to leave that. And then a to the negative, and then b to the 0. We'll come back to that in a second also. Okay, so that's how I've been doing the other ones. Do the positives first. Now let's deal with this negative. Now it goes down to the bottom, right? We already talked about that. So this will be 3ab cubed, and then still, now it's a positive 2. So we've dealt with that one. What happens to this b to the negative third? It's going to go down to the bottom, and it becomes b cubed. And then what about this a to the negative fourth? It moves up to the top, and becomes a to the 4th. And then what happens with this b to the 0 power?
1.
It's equal to 1. And does it matter if I multiply by a 1? No, it doesn't change anything. I'm going to write it there just so that you don't think it just disappeared. But this one right here turned into this 1 right here, which in our next step is just going to go away because you do 2 times 1 and then it's gone. Okay, so let's see what we can do. On the top, do we see that we can simplify this a little bit?
Yes.
A
5
times a to the 4th will be a to the 5th. That's correct. And we have a 2. I'm going to go ahead and do the 2 times 1. That's still a 2. But we need to deal with this. In fact, I'm going to put the 2 in the b cubed. But we need to deal with this parentheses. So that's what we're doing now. We're dealing with the parentheses. What happens when we have 3ab cubed and that whole thing is squared?
What's your question?
What do we do with this?
Multiply 2 times square.
Apply to
The squared goes with everything, right? So this becomes, if you remember from last
9.
week, 3 gets squared, a gets squared, and b cubed gets squared. Do we remember that parentheses rule from last week?
Yeah.
The exponent applies to everything inside the parentheses. All right, so our numerator, still pretty simple. We can just leave that alone, but we've got to deal with this denominator.
So why did you put the parentheses just for the b?
Oh, we can put it on each of these, but because there's only one
Oh, I see.
there's only one
That's
exponent
long.
attached to
Got it.
the. Okay, does that make sense?
Yeah.
Okay. So let's go ahead and simplify. We still got the 2b cubed. What is 3 squared?
Seven?
Nope, that's cubed.
9.
3 times 3, 9.
Mhm.
You're right. If you were doing 3 cubed, right? You did it 3 times.
Yeah.
You just need 2 because it's squared.
Oh,
B.
The a squared is still just a squared. And then what happens with the b cubed squared?
B6.
B to the 6th. Okay, so let's keep cleaning up. Again, try and do just one step at a time until you get some practice with these. To deal with the numbers, we've got 2 times 9, so that gives us
18.
18. And to put it in alphabetical order, we'd have the a squared there. And now we have the b cubed and the b to the 6th. What will that equal?
9.
B to the 9th. All right, well, now we're looking a lot better. So thinking about the numbers, do we just have one number? And again, it can be a fraction, so that's okay. We just have one number, right? 18 on the bottom. So that's good. Notice we've got A's, both on the top and the bottom. We can't have that. We only want one thing of A's. So what do we do with the A's?
subtract.
Subtract. So there will be a to the 3rd power left. And will it be on the top or will it be on the bottom? It will be on the top. So a cubed will be on the top. And then b to the 9th, there's no other b's, so we just leave that where it is. And then this would be our final answer.
Yeah.
And again, I want to stress, I know that this looks like a lot of different steps. There will be, again, as you get used to doing these, there are some shortcuts that you can do. If I was doing this myself, and in 2 weeks when you're doing this, you probably won't do every one of these steps the way I've shown it. Because, again, there are some shortcuts. Like,
I see what the shortcut is now.
I mean, there are a few shortcuts that we can use. So it's fine if you use them, but I don't want to confuse anybody on what the rules actually are. Question?
Can we see where, go back where we got to 18? That's what I can't be finding.
The 18?
Yeah.
Okay, so right here, we didn't do anything with the top. It was a to the 5th,
Mhm.
but we just started simplifying the bottom. So what we did to get the 18, multiplied the 2 times the 9.
Okay, multiply.
So 2 times 9 gives us the 18,
Okay.
because that's just numbers. They multiply.
So-
Yep. And then the a squared just stayed as a squared.
Mhm.
And then the b to the 3rd and the b to the 6th, when we multiply those, we get b to the 9th.
Okay. I got
Okay.
a little behind there with trying
Me
Okay.
too.
Yeah. Does that make sense?
Yeah.
Okay. All right. And did the rest of it? Were you able to get the rest of it, or did
Yeah,
that get you
I-
behind? And
Yeah, I can catch up.
okay. Okay. Not just staring at it really hard.
Nope, I think I got it. now.
Got it. Okay. And Sally's packing up. Is that done? Are we done? Is that? She's like ready to go. I'm out of here. Okay. So that's the end. Now notice again, there are 12 problems here. Make sure that you still, some of you have, I know, and some of you have not, I'm guessing, done section 5.1. So remember, section 5.1 is just all the little rules. So those problems are going to be shorter and quicker.
What, you get more?
Well, you get 3. Well, yeah, because you
No,
get
I
2
don't
chances.
get to tally, I don't get to.
Okay.
What?
It's okay. It doesn't matter. So just take your time and remember you're using those individual rules. Then when you get to this one, some of these are going to be short because it'll be just like, oh, something to the 0 power, and you're going to write 1. Or it'll be something to the negative power, and you're going to make it a fraction, make it the reciprocal. And then you'll get to some of these at the end, which will take a little bit longer, but take your time. And again, if you see a shortcut and you want to take it, that's fine. I didn't want to try and teach you a shortcut before we really understand what's going on.